Alrighty, hello there. Nobody showed up yet, but I'm sure they will. Welcome to the DIY stream. As usual, starting up kind of slow, and we're going to get our stuff together and start doing things. As usual, and I can do a crazy feedback effect here and start doing by monitoring the output coming off of the speakers, because we're monitoring through the speakers today. And I can do a crazy feedback effect here, so by monitoring I'll have that going output coming off of the speakers, because we're monitoring through the speakers today. Chat window, and I can do a crazy feedback effect here, so by monitoring, I'll have that going output coming off of the speakers, because we're monitoring through the speakers today. Chat window. There's all kinds of silly things one can do. I can do a crazy feedback effect here. So this is actually the one I was even planning to do. So I'll have that what it was. Well, the speakers, because we're monitoring through the speakers today. There's all kinds of silly things one can do. A crazy feedback effect here. So this is actually the one I was even planning to do. So he says the price what it was. We're monitoring the speakers for a long time. There's all kinds of silly things one can do. But what I'm going to do is stop that and get real. So as you can see, I'm holding this, and this is to try to avoid feeding back too much, because I have a variety of things set up. And I think if I clip this here, I can kind of yell, and you can still hear it a little bit, even though we're not going into terrible feedback. I'll grab it and speak directly into it when I need to. We've got some stuff set up. Here's one of them. I have this dialed through so that I can move the camera around to show various things. And I have a jack from one of the inputs. You actually can't hear that right now. Here, tell you what, I will switch the input to not attenuated. We've got the input going through the live stream. Hey Jess, hey word constructor. Yeah, we're going to be word constructing today. Let me pad that again. And that wire goes over here to this, which is my output bank. And I'm not really quite sure why this is. Oh, that's better. Yes, I can adjust this so that it's not a nightmare. It's still crazy, but it's not too crazy. So I've built this. And what this is my modular system as a output stage. And the red wire goes into those little pin headers that I'm using for everything. And then I've got Eurorack style jacks hooked up. And I got wires going to all of them. So what I can do is get 8 Eurorack outputs, which are the same as I use over here for the synthesizer system. And I would have those plugged in over here, except that I have one of these. And I got this because I was asked to do a filter based on it. And I've got it hooked up to these white wires, meaning that I can't unhook these and drag them all the way over to here, because the white wires are hooked into the back of this. So it's all very complicated here. I also got another camera angle handy. That little crazy mobile cam is really more designed for when I start soldering something, if you need to see what it is that I'm doing. But I've got this auxiliary cam and my regular cam, and we're going to give this a shot. I might also see if I turn this up too much. Actually, hang on a second. That's not as bad as I thought. Here. ASMR from removing this thing. I think maybe if I just don't turn this up too crazy and leave the other thing here from getting too loud, as long as I'm willing to raise my voice a little bit, or I can even turn this down a hair more, I should be able to use that. Cool. Okay. As always, this is a work in progress. I am trying to get the DIY stream thing going. And I'm going to go for a couple of hours, as I have been. I'm going to take a moment and pause that image so that it doesn't distract me too much, because that's a problem. Always got to be fiddling with everything doing this stuff. But here's my hope is, here, let's go over to the hand cam. Here's my soldering iron and multimeter. And here's what we were working on last time. And I built something. This is a power supply that's supposed to give me 12 volts and 5 volts against ground. As you can see, I have a ground wire hooked up going over to the power cable. And it's running off of a disk drive controller. The things that you see over here, those are 1 amp fuses. And they're dispatched from another little pin header thing, from the one over to these strips, which are just wired together. There is, I wonder if you can actually see it. Let's crank up the camera and let's see, can we see underneath? We kind of can, cool. So this is what I'm doing. The cables there are coming from a disk drive power supply, much like a PC power supply. It's running on wall current, and I feel like it's providing, as much as 2 amps, so I'm a little more cautious with this. And the backs of those pin header things are all wired together like this, but nothing else is connecting to them. They're not wired directly to the power supply here, because they are wired through these 1 amp fuses. You can see how those are patched in. There's even one on the ground. It's symmetrical because of the kaleidoscope technology here. And yes, I do have a 9-volt battery spotted. That's for if this all goes terribly wrong and I need to get something happening. And what you also see is a capacitor. And this capacitor is the one I was trying to use previously, where I had the impression that it was broken. I kept hooking these up to my circuit here and having the circuit just go totally dead. And I was like, oh no, the reason these were so cheap in wholesale was because they were all broken. They're 25-volt capacitors, but they're all dead shorts. I don't think that's necessarily true. I had a look at the battery, and the battery that I used was saying like, oh, it's about 8 volts or so. So I was like, cool, that's fine. Well, check this out. I've got my multimeter, another battery. And if I connect this one, it says it's 13 volts. This is only a 9 volt battery. I think this multimeter is basically garbage and is not giving me correct values. So I'm a little, like, I'm not entirely sure. See, if I set it to 200 volts, it claims that it's 29 volts now. And interesting thing is, let's see, oop, I might be able to show this on camera or possibly not. It is a little challenging with the filters that I like to use on these. I'm getting a bit of a haze effect happening. But I've got this power supply over here. One of the things I was thinking about doing was adding some LEDs in there so that I could see when it was on. And right now I've got the multimeter touched, the black is touched to ground, and the hot is touched to the red. If I turn it on, it's fine, except for that it thinks it's, let's see. It thinks it's 16 volts. And then the 5 volt one, it thinks is 8. So it might be calibrated. My suspicion is that this multimeter is not giving me accurate results. And as a side effect of that, let's see. If I grab the battery again, connect it like this, and then let's see, correctly touch this to it so that this is a little challenging. Let's It's always going to be a bit of a mess like this. Don't let it bug you. Let's see. You need to sit somewhere without falling over. Let's use this tripod to stop you from falling over. Like that. There. So if I touch the battery like this, and then take the capacitor, and now that I have a real battery that's not dead, and touch that to the same things, hey presto, all of a sudden it's not acting like it's a dead short anymore. If I touched it backwards, it'd probably blow it up, because it would be reverse wiring the thing. So it seems as if, like, see, I'm continuing to hold the voltage. Here's another capacitor, fresh out of the packaging. Touch the minus to the minus and the plus to the plus, and nothing happens. And this is the reason why I'm interested in this, is because I was very panicked about the state of these caps. I thought they were all broken. And if they had been all broken, then I narrowly averted disaster, because if I put them across the 2 amp capable power supply off of an old disk drive, I'd be seeing smoke and maybe fire, and we don't want that. Or at least I'm assuming we don't want that. Maybe for the purposes of YouTube's, it would be good, but mostly we don't want that. I am in many ways a fairly serious fellow, so I'm not sure about doing bozo stuff just to be entertaining. In fact, I intentionally avoided something just like that this morning. Because here's another thing that I've got. The other day, I went and I got a COVID shot. And this is one of two, and I'm going back early June for another one. And I had a fellow writing me on Gmail, writing me on a whole bunch of email addresses, in fact, and very concerned and panicky because he wanted me to watch some kind of thing from one of the denialist groups out of Germany. And I'm like, you need to trust me and maybe not trust the people that you are trusting, because you're being conned and it's not good. So I thought what I could do was set up my wacky visuals thing, as you can see, and set it to a really crazy background image. And then take some green screen material, or I actually have a green screen suit. I could put it on my hand and like hide my hand out of shot and say, oh, hey, and I went and did this thing and it went great. And I'm not feeling any effects, although my hand's kind of tingling, and then lift my hand into shot. It would be all special effects and stuff using the green screen. I even was going to do another gag on it, like, oh yeah, now I can apparently make telephone calls while I sleep, although I'm not sure what I'm saying. And I know the first 500 digits of pi by heart. It's actually very easy, 2.99999, and multiple layers of gags there, because it's like, okay, I am a robot and I've been taken over by the evil monsters, and not only that, I have become subject to the floating point bugs and believe that pi is 3. And I didn't do any of that stuff, because some of this is not funny and some of this is not really a joke. So I'm going to try to be gentle with people who seem to be like hooked up with the crazy, but I don't like it. I don't like that. I would like folks like that to grow up a little bit and find better people to listen to. I'm not going to go around giving people political lectures or anything like that. If you want political lectures, you should go to Beau of the Fifth Column or Vaush. Both of those guys, I think, are very smart. And they're going to say stuff that I'm not going to say. And I'm not going to be running around disliking people or refusing to help people, because I feel like one of the ways that people can get into jams like that is if life is really hard and they're in a lot of danger and they're under a lot of stress. One of the things I'd like to be able to do is relieve stress. I'd like to feel like if I can do my stuff and I don't do it at a wildly accelerated pace, like if you're catching up with my building streams or anything like that, it's going to be happening in a pretty sedate way. And I'm going to give people the ability to do stuff, even if your resources are not great. And in that, that will help, hopefully, make the lives of a number of people a little bit better. That's the hope. And they don't have to be wealthy or secure or know where they're going to get their next paycheck or how they're going to pay rent or whatever in order to do it. These are important things. So that's why I decided not to do a bunch of silly jokes to be edgy, because as you know, I'm not an edgy type. And that's a choice. So let's go back over to this view. Jess, as far as the pi is 3, there was some kind of school district in Kentucky or something like that that legally made pi 3 briefly. It didn't go over very well, but it's a multi-layer gag. Arcane Audio, I'm not going to get into it. I like Vaush. I think one of the things that's interesting is that when people get into that kind of stuff, it is generally the privileged who have the resources to do things that are useful and effective. That guy's ability to know what's going on is in part through coming out of privilege and your ability to have Airwindows plugins is because I, in many ways, came out of privilege. I didn't know it because my family was kind of screwed up, and it got complicated, but it is the truth. And so that gave me the position to be able to do things like make free plugins and survive for long enough for the Patreon to pick up and so on. It's like, there's a bunch of complicated stories, but that's really not what this channel or what I do on a daily basis is about. Oh, and you're noticing the cards. I can talk about that too. I'm going to shuffle things around on my desk a little bit. Here, let's go to a close-up view of the cards, or even Razer, whatever its name is, Razer Kaio webcam, and Manfrotto Pixie tripod means I can make a little stand that can face down onto something. You can see more or less what that looks like there. And I can put down these cards. So here's what this is about. I've been trying to come up with ways of doing sort of gamified music composition for some time now. This is the recentest one. It's a whole set of cards, and I started off, here, I'm reaching over so that I can grab something else. I'll show you what I started with. There's yet another bank of cards, previous attempt. There we are. So, here's the first try. The underside of these became that slide rule that I made. Yeah, Arcane, I will say this. The thing that I don't get along with as far as Vaush is concerned is that he loves being an edgelord. And that's why he attracts the people that he attracts. And that's also why he's constantly going like, I will commit suicide in Minecraft on his stream when his chat drives him up the wall. Because he has all these young, edgy followers who are not particularly mature. And that edginess is what makes that guy be a preacher. And also that he feels he is entitled to tell everybody what to think and all that kind of stuff. As many people do. You know, that's the only bit that I don't really get along with. But as far as his grasp of how things work, it's correlated pretty well with my understanding over a lot more years of experience. And I've had the capacity to be able to watch stuff and try to learn from it. So I've had time to analyze how things work. Indeed, I make my living off of being able to intuitively get stuff faster than your average bear and come up with something new on a weekly basis. And I did that for 10 years before going on Patreon too. So I do depend upon my ability to think and figure stuff out. Now here is what I did before the current bank of cards. I'm thinking about making sort of like different colors of arrangement styles, and I used the colors, actually this blend and tilt, that's the black and white, but I started with a set of colors based on, man, there's a lot of overlap, based on sort of 6 central colors, and I was going to go with like, okay, this is fire, and this is lava, and this is nature, and so on. And I made pairs of qualities like tight and relaxed, dense and sparse, slow and quick, and did pairs of colors that could be combined with other pairs of colors. Like you could do this, where your sequence would be like starting with gray, then red, orange, and red. And my idea was that you could make arrangement decisions that had some things in common with like song structure like ABAC, verse, chorus, bridge, chorus. And as you can see, I've made a whole deck of cards. The great thing about this is if you want to do something like that, you can get Sharpie markers and draw on the backs of regular playing cards and then shuffle them. They're very easy to work with. And so buy a bunch of playing cards and start experimenting with what you can do with them. And it's a handy way of getting that online. So there's a whole thing that was going to be made out of needing to combine, like deal out a deck of cards and then arrange them in such a way that you were making alternating styles of music or whatever, rather than just randomly throwing a bunch of stuff in a pile. I ended up not thinking that was the greatest idea because it was a little bit too random. It was a little bit too aleatoric. So what you see here when we've got these going on, as you can see, there are some similar things, like the words written on there are in some cases taken off of previous instances of the card. I peeled them off and put them on the next one. I arranged the pairs of things slightly differently. I just heard a noise over there, but I'm not sure what it was. Maybe it was just wind. Anytime I have a powered thing going on, I get nervous if there's a random noise because I'm afraid something's catching fire or blowing up. So the deal here is I did the same thing with these. And I made a whole range of this stuff going on. I'm trying to look through these and go, did I use black and white as well, or did I just use all the different colors? I think I might have cut it back a bit. Yeah, I think I kept it to like 8. I'm not sure I went all the way towards including black and white as a color. I may have, though, because I liked that idea of having black mean tilt, and tilt means make some kind of drastic, abrupt change, and white means blend, which means gradually fade from one thing to another. It looks a lot to me like I skipped using those in what I've got here. But the idea is that I've got all the, oh, hang on. One of the things I'm hearing is my wire there. I tried to make a composition based on these ones and more or less failed. It didn't work out in the way that I wanted. What you see here is me trying again. And the idea is you're supposed to be able to do that and then go, okay, the one that follows is going to be this. Or this. And to some extent, and this makes another sequence here, the ones that you get dealt, you're going from relaxed, dense, and cold to relaxed, dense, and quick, which is a very small change, to tight, dense, and slow, which is a more abrupt change. I haven't done these yet. I've done some fooling around with the chord slide rule, but I haven't pursued this that much yet. But this has a characteristic, which is the color changes up top are always more closely related, and the color change in the bottom is more distantly related. each color has the option to go to each of the other colors, and that's what the deck of cards is made, is it's offering all of the different variations in it, and the two choices are always going to be more of a chilled, not much of a change option on top, and a more aggressive change on the bottom. Like with this blue to orange, those are literally opposing colors. And the idea is I might have a unrelated thing going on where if you made an arrangement of these and the choices that you made always went along the upper path, it might not be desirable because they would be too chilled out of a change, whereas if you always went along the bottom path, it might be too choppy, and so you might want to do a sequence that went through a series of changes and wound up on the same level and at the same color. Like you'd make a loop and it would go sort of up and down respectively and come back to the same place, and that might prove a satisfying composition. And that's what that is. As you can see, these are the things that I work on. I honestly can't say as that has borne a lot of fruit yet. I don't feel as if I've gotten any good compositions out of it. It's trying to do something that becomes a aid. And sense-tube, interesting thing about that is if you wanted, you could make it be hot, meaning loud. You could choose any kind of associated words to go along with these. I'm picking words that feel to me like they might have a relationship to arrangement, a musical arrangement, but they're not keys or time. Oh, hang on. I think what ended up happening is this. For each color that I used, there is one card that has a white and black option, and the white option is blend and the black option is tilt. The black option is abruptly do something else. And you could match that to any other color. The point is that the transition needed to be aggressive, and on top, whatever other color you pick, the transition needs to be basically like a crossfade, very smooth. So I did have those colors incorporated in this deck, it's just that they're very rare, rather than cropping up all the time, because there's only one instance of this, choose a transition type in the entire deck, which is like 2 decks of cards, so it's like 104 or something like that. Most of them are one color transitioning to 2 optional other colors. So yeah, I'm working on that. If I can come up with anything that's good, I'll probably make up cards and try to sell them or something. And it's most likely also going to be a Creative Commons, like download the files used to make it. You could by all means form a card assemblage and squirt Vegemite on it. That sounds like a dandy idea. So here, where we were at as far as this is, I wanted to get this fired up again. And there were a number of things I wanted to try. One of them was wiring up LEDs so that I could see what this power supply was doing. As I suspect that it's more or less about right, and it's the multimeter that's at fault, because that's the case for the battery as well. But what I was doing with this is making an oscillator, and I can continue to make my oscillator. Here, might as well drag over the work cam. The whole idea was I needed to make this so that you could see what I was doing. We'll fire up a light. Put that down there, and I'm going to adjust the width of chat. I can more or less see what you guys are doing, but I can use chat to see, now chat looks as if it's a mirror because it's using part of the where my funny little camera reflects stuff, and the other reflection you just have to live with. So there, now that I've done that, I want to do a couple of changes here. And I'm going to go dig up another one of these because I want not just a power and ground output. I also want, I had a output hardwired to this. I don't want that anymore. I want the power, ground, none of these hardwired wires because I'm going to use the jacks the way they're meant to be used. So I'm going to be desoldering some of this. And then I'm going to put another in, which is going to be the audio output. The labeling isn't really as good as my power supply where I have bits of tape on there. And then I'm going to take this off and set it up so that I have 6 oscillators rather than just one, which I believe I can do by you can see where some of these are wired together, and I'm going to take that away, I think. So let's get soldering to the extent that I can do that. I mean, the thing about, like, you guys, do you remember the chord slide rule? I've got that handy in case you wanted to see it again. I'll just scamper over and grab it and show it to you again if you want a reminder. But the whole thing about the chord slide rule is that it's anything but random. It's far from random because it's showing all the chords that'll work in a key, whether they need to be major or minor, and then a range of other chords that are more weird and unrelated. And how far they are away will show you how weird and unrelated the chord is. So it gives you like a jazzy simulator. Shows you how far out the chords are going to be. A noise with my wire stripper falling over. So let's see. Firstly, this didn't need to be there. There. Spare wire. And now this is a little cleaner. And you know what? I'm willing to bet that I could put the capacitor back. I feel pretty confident that I have established that that capacitor was not at fault. Although I will note, we could also put the capacitor back by simply plugging it into these little holes. These connections are real good if we have enough wire available or enough of these jacks available. All you got to do is push it hard enough that it plugs in, as I just did. And that's now a real solid connection, and that's a better connection than most breadboards. So this is now pretty much as good as soldered into the circuit. Now that doesn't mean I'm going to stick with that, because we might want to have those available to plug other cables into. The whole idea is that this configuration is for being able to use with cables or cable-like things. But my hope here is I want to get this fired up And maybe what might be good is, I'm pretty sure this was patched through kind of like this. You can kind of see where I have it coming out. Because I needed to put it into, yep, see, there we go. If you put it exactly here, you can still put it onto the Eurorack style rail and it's not going to touch anything. I've got to put it in backwards, mind you. The minus is next to the red part, which is plus, so I'll reverse it. But I should be able to scooch this over and then wire it to where the, hang on, I've got, this is so bright. Move these wires over so that I can sort of solder touch them up to where the original design was that I made these connections out of however much of the capacitor's leads were left over. So I can kind of just continue that. Bent them over, and they're more or less touching where the other wires went. And let's briefly solder these together. You know, something else I'm going to do, you might or might not hear this, but I have got a ceiling fan, and that is for the purpose of making the solder fumes go away from me, which is important and good. Be careful with doing soldering and all this kind of stuff. Because again, you don't want stuff blowing up in your face. You don't want to be inhaling all the fumes and everything. You got to take care of yourself to some extent. So there's one wiring. There's another. See how easy that is? You probably were able to see that at least a little bit. Here, I can probably give a little bit of this light on the subject. There you go. But yeah, I'm heating it up by touching it to the wire and then just very delicately touching the solder to the piece of metal that I'm soldering rather than to the iron. The iron's tip has to have solder on it. It has to be wet with solder in order to communicate the heat. But once you've done that, the part that you're soldering is the part that you touch the solder to. Feels more than a little bit like I'm just getting glare off of this. So having done that, let's figure out firstly, well, let's do a bunch of things firstly. Here's one. We're going to deconstruct this whole section. We're not even going to be using this type of potentiometer anymore. It's still there, still probably good to use. But here's another wire that's been released. This, I think, was never actually soldered to anything. And this capacitor is now loose as well. Because remember, the way we can make this work, and this is the secret, this is what I'm going to be getting into, is these little connections in here that are part of the and one thing I'm going to need to do is, hang on. Putting that mic down for a moment. I did not do this work in advance. I should have, I didn't. But I still have these operation sheets. This is the one that I need. So I didn't do this work. This is still just blank. But I have the data sheet that I'm going to use to reference this, and the back of this tells me what I need to know about this. It's a pity I can't have everything visible in some kind of fancy video thing. I'm fancy video thinging as hard as I can. Maybe I'll make notes on the paper. Grab a pen and we'll see what we can get. So yeah, there's our reference. It says top view, which is this. I got confused and had a problem earlier because when I went for the top view, one of the things I did was, I'm angling this around in hopes it's visible. There's a dot that is shown, and there is a dot on the chip, but the dot on the chip is not what I needed to be referring to. The, oh, there it is. That little divot on this side corresponds to what the dot on the chip means. So when it says things like, oh, now it's upside down. Hang on. Do my best. If I get better at this, it might actually be helpful. If we have things like this, say top view, and we're looking at the chip, which you can't really see, and it says 1A, and the dash on top means inverted A. This 1 and 2 is one of the inverters, the Schmidt trigger inverters. And we can see that this divot in the chip also refers to the inverters, meaning that these two are an inverter. The one on the very end is the input, and the one right under it is the output, and so on as the chart goes. The dot is not the ground pin. Ground pin is, if I'm not mistaken, VSS. That is farther down this page. There. So VSS is the farthest away from the dot on this side. And as you can see, I have a black wire that's connecting to it. So ground pin is actually connecting to this ground part here. And as you can see, I've got stuff wired to this already. I've already been using this. This was the input, this was the output, and there was a potentiometer between them. So something I'm going to do just quickly here is break those solder connections real quick. I don't want to have the chip soaking in heat for a really long period of time. Grab this, which is a sculpture tool. It says SH06 Sculpture House. Got this at like Michael's. And I'm just going to bend my pins a little bit using this. Seeing as I've got this in here anyway, and might as well run with it. I'm also going to quickly take these bits of wire off. If I can. Is something sticking through here? Yeah, there's a bit of wire poking through one of these holes. It's not making it impossible, but it's making it a little bit more difficult. And that came off. And I pull it out. And this, I think, is going to be easier. Sure enough. So now we have just red wire is going to the V positive. Ground is going to the V negative. None of these are hooked up yet. Oh God, I'm sorry, my microphone is really far away from me right now. I forgot to put it back on. I'll get better at this with practice. Let me do that. Okay, now you should be able to hear me pretty good. So, here's my pin function thing. Here's this in top view. Meaning that this and this are a connection, and this and this, and this and this, and then is ground. By the same token, on the other side, VDD is this wire. Then this is labeled all weirdly. This now says F and L equals inverted F, and then it says E and K equals inverted E, and then, oh no, wait, the other one said the same things. They're lettered, and they're all lettered in a really weird and goofy way, but that doesn't matter. This reference chart is dumb. I honestly feel like this is a very silly way of arranging it. But VDD, then again, 13F and 12 is inverted F, meaning that we have another connection there. Another one there, and then the last one is tucked over here opposite to the ground wire. And those are the inverters in there. Those are the things that you connect together in order to get it doing a thing. Yeah, I know the mic was fine, but it was pointed away from me and towards the chip is a 40106BE. Which is actually a bit weird because that means it's a buffered output, but that's probably fine for what I'm using it for. There are certain kinds, like the 4049 hex inverter, where you would want to use the unbuffered output version. And it is a electrolytic cap. Again, I'm pretty sure this is actually going to work. The reason that it kept like killing the power is because I was running this circuit off of a battery that was essentially super, super dead. Folks, ESR means equivalent series resistance. Everything matters. The question is what it's going to make it do. Now, what I'm going to make this do at the moment is I'm going to draw these designs again. I'm going to draw this, this and this on those sides, and same deal on the other side. These show us where our connections must be if we're going to make these Schmidt trigger inverters turn into oscillators. Is the whole concept of how this circuit works is that you connect those pins together with the resistance, and then you can put a capacitor on the input. The input is always closest to V++, which is on this side. So if I flipped it around, we connect a potentiometer, or indeed a resistor if we wanted a fixed frequency, between those 2 points where I've drawn a little bit of Sharpie there. And then for each one, see where red means the V++, and it's wired to this top corner over here. Wire a capacitor to the top of each of these pairs of connections, and we'll have 6 oscillators just like that. And I have a bunch of capacitors handy, and I have an idea as to which potentiometer I want, just to see, because this is my collection of potentiometers that I have in a Planters peanut jar, as it's a snack that I like to eat. Remember how I got things wholesale? This is one of those times. I bought huge numbers of these. These are some of the ones that I can give away if I would like to have people be able to follow along at home and do this as well. I don't have to do the Bob Ross, make you go out and buy your own things. I should be in a position, thanks to the privilege we talked about in the voucher discussion, to literally send you off stuff. Because like, I reached that point of the Patreon where it's like, I'm earning enough with that I've got my monthly stuff covered. And I could turn around and just start sending stuff out to people and doing this kind of thing. Now, that said, I distracted myself a little bit away from doing one thing that I meant to do. I meant to put an output pin in here, but maybe it would be better if the output pin wasn't up where the power supply is, but is farther down here, because there's a bunch of stuff that I can do. As you can see, I've done things with this already. This is drilled out. My hope is that I can come up with a way of wiring these in so that I have 6 of these, and I can run the wires over to the pins and then add some capacitors. Here, I'll throw some capacitors down as well. Six of the trim pots, 6 of these, and I will have 6 independent oscillators, and then we can play with those. So about an hour into the stream, I feel like this is a reasonably good time to dive in and start doing that. So I'm going to scooch these extra little wires and the tantalum cap that we're not using right now. And let's try to find a place for these to go. Because this is part of the deal. This is part of what I'm talking about with this stuff. Is if you were to be doing this, you should be also willing to just fool with stuff and experiment and try to see if you can get stuff to happen, make stuff work. So let's see, first thing I can do is clip off these little bits at the end, which are where it's attached to the tape packaging that it came on. Because this stuff came on tape rails. Now, when I wire these up, it'll be kind of like this. But this takes up a little bit too much space to easily make it be wired up like that. But when I wire these up, one of the leads can fold over and just touch to the pin. In fact, the lead is the one that needs to also touch to the end of a capacitor that goes to ground. So that's useful. And then this other wire, I have to run a little wire between this pin that isn't as long and the other one. If I was to use both of the long wires, all that would happen is it'd have a fixed frequency. Although one thing you could do is this. This would work. Bent the firewire along and used it as the wire to connect to the chip. That said, I might not want to go with that, because the fact is I can't fit 3 of these in here that way. They're too large to jam right up against the chip and have them be able to fit, so I'm going to have to space them out a little bit. The way you go from control via potentiometer to control voltages is hook the one end of it to, like this. This is a 200K resistor. This is minus. You could hook this to ground. This is plus. If we do this, that middle thing is now a control voltage. That's normally how they do it. And that's also normally why you'd use a high enough resistance that it's not burning up the thing. If you had an incredibly low resistance, a lot of voltage would pass through it. But doing this literally gets you your control voltage. It's going to get you that middle thing, which is the wiper of the potentiometer, going from ground potential to full positive potential. That's how it's done. Now, that's not how we're doing this, because the chip is going to generate its own voltages. So what we're going to do now is try to figure out, firstly, let me clip the ends of some more of these off so that I can place them. Like, as you can see, the ends of them are these little spade-like things. And that's because that's how they're connected to the tape that it came on. Just a little cardboard tape with some masking tape holding it on. And I'm clipping them off in order to be able to manipulate them. Technically, I can still poke those through the holes, but I'm going to have to trim them at some point anyway. So I'm going to put my spare ones in here. Scooch that over. And just for the hell of it, let's count out 1, 2, 3, 4, 5, 6 resistors and put these away too. Now you'll notice I'm using the tiny little polystyrene capacitors. I've got a couple of different kinds in here, but they're all the same. They are 4,700 picofarads. And they're 50 volts or better, because little tiny film capacitors can take pretty high voltages. Little tiny film capacitors do not have polarity. That is correct. Electrolytic capacitors have polarity because they're not constructed quite the same way. Electrolytic capacitors are they're almost like they're automatically shorted out, but then there is the electrolyte that is capable of producing a resistance, and its properties are what causes the capacitance. Electrolytes work in an interesting way, which is that they can be self-healing you can have a connection where it's such a delicate, tiny connection that tiny little areas can short out. But if they short out, there will be an electric current that moves the electrolytes around and seals the hole. So electrolytic capacitors operated under voltage are self-healing. This is not the case with like the film capacitors, or especially not the tantalums. If you break the tantalums, they just blow up. Perhaps not super violently, they're not like bombs, but I believe they can bang. I'm going to try to avoid having that happen. So here's the deal. We are now going to try to wire up 12 wires and 12 little chips, and I am now wondering what would be a good way of hooking this up. This is almost like designing a GUI for a plugin, which I don't do, but I do choose where the voltages and things go. Oh, also I see in the, I had not noticed until now that these have numbers drawn on them that you can't see because the camera is not willing to resolve them. But with my new glasses, I can see them. Over on this side, it says 204, because this is a 200K. And that's important. It's especially important because, oh, that's what's making the noise. My wire is getting trapped underneath the wheels of the chair, which is probably bad for the wire, but not the chair. So yeah. Would this be a good arrangement? All of the potentiometers in a row, or maybe side to side or something. They just have to be consistent. And I'm going to have room to wire the things together, but I could also use the end of these as the wires I'm using to connect things. That might actually be a good idea, because my primary wire for hooking this stuff together is very heavy. And that's going to have some positive sonic benefits, but it might make it like hooking 12 wires that big up to this chip is going to be a bear. So maybe let's not do that. Another possibility is setting the chip up lengthwise and trying to put the potentiometers on either side of it, which would kind of work, but might not work all that well. There's two problems with that. One of them is that there still isn't enough room to wire all of them into the chip. And the other problem is these are sticking off the end of the board here. So it's not really arranged very well. And one of the things I'd like to do is have enough room to do other things as well. But I do feel like the first order of business is making it work at all. So maybe that'd be good. Let's try. Again, here I am trying to decide how to make it be wired up. As I'm feeling a strong temptation to wedge everything as close to the chip as possible, that might not be... oh, dude, As far as the heavy gauge wire, it's good sonically. The heavy gauge wire will have far less resistance, or well, not far less resistance, but it will have less resistance. But it's going to be much harder to solder together because it's much more rigid and it's much bigger. Here, I've got some of it right here. This is what we're talking about. And if you put it up against these connections, it's kind of large, this, and that will make it a little harder to wire stuff together, because you can like poke it into these holes and touch the soldering iron to it, and that will effectively make a connection pretty good, but it will hang on to more heat from the soldering iron. So everything will stay hotter. There's the possibility of damaging the circuit. And then once you've done that and you're trying to connect it to like something over here, you've got to bend it over like this. Getting some tweezers or something might help with that. Whereas something like this, you can still touch it to the pins and solder it. It will retain less heat, so it's safer for the chip and much easier to bend around and much smaller and less likely for it to sorry, my lungs are bothering me. Tiny wire is easier to work with, but slightly higher resistance. And if you take it too far, there's a sonic detriment to the circuit. So a lot of sounds you can get out of being able to make the circuit really carry a lot of energy, particularly for things like the square waves that this generates. Square waves take a lot of energy. The transition between one side of the square wave and the other covers a lot of, it's a very quick, this is I think one of the reasons why tubes have the sound that they have as well, is because it's changing electric fields directly rather than pumping them around using a semiconductor junction. So let's see, I'm wondering whether maybe it would be a good idea to just wire one or two of these up and go from there. I don't know. I think it would be a good idea for me to go and grab the tweezers I mentioned. I'm pretty sure I have some of those around here somewhere. Unless I don't. A little hard to tell whether I do or don't. I thought I did. Or have I got them hanging on the edge of something? Yes, I do. Tweezers. I had them hanging on the end of a sort of pencil cup. So that's going to make it a little easier to make some of these connections. Still mulling over where these things should sit. I could pack them very tightly like this. Or put them all in vertically like this. It's a symmetrical layout, so that might be good. There, they go down vertically like that. Yeah, maybe that'd be good. Because we don't actually care which of these oscillators we connect to, as long as we do. Like we can pick fairly arbitrarily which ones we wire to. They just have to go to the correct places. So how's that looking? Maybe we'll do that. Because the secret here is we're not necessarily going to stop here. Oh, running into a problem. They don't quite want to fit. They're tilting away from each other. They don't quite fit in this one, but do they? They kind of do. Let's put the last one in and see. Yeah, they're not going to want to fit that way. If I put these in like this, they're going to try to tilt away from each other. Yeah, the chip is pretty robust as far as that's concerned, but the soldering iron is still going to melt it pretty good. But if I arrange them the other way around, I will be able to pack them that tightly. Let's do that. See, the idea here is I like to make them start all going, but do it in such a way that there's the capacity to maybe sneak in other trim pots and cross-modulate them with each other. There's also the possibility of putting a 4049 chip in here somewhere and having the triangle wave outputs all be softly distorted. I could do that, I think, with very little in the way of additional circuitry. You'd basically just run the output straight to the CMOS input and then maybe use a feedback to get it to distort. We're starting to drift into that zone where I'm talking gibberish because this is going beyond what words will serve. That's how we know we're getting into working with stuff that's in the intuitive space rather than... Oh, I see a problem. See where this is? Here, I'll use the tweezers. These two things are things that need to connect, but they're off by one from going straight across to connect to a thing. In other words, this needs to go to this, and this needs to go to this. And that's a fairly tight configuration. Or they could go oppositely. We can go this to this, and then this to this. Either way, though, that's a fairly tight packing. Let's run with it. So you bent that a little and you can't see it, can you? Dang it. Bent that a little ways over so that it clears the other one. And with a touch of solder, we're good. There. Our first wire, yay. And you know what? Like I said before, the far side of the potentiometer could be just clipped off, but I can also bend it over here. Oh, I need to grab the tweezers again. It's not bending nicely. That could go on either side of it, but let's make it go to the far side of it. And the near side of that. You might or might not be able to see what's going on here. But that looks like I have two connections right there. It's a shame I can't get better magnification on this, but this is as good as I've got for now. That is a connection, and lastly, and that's definitely a connection as well. You can see, hopefully, that it's a very small amount of solder there, but where that little black line is, I've got two of these guys hooked up. And remembering that our capacitor touches the input because it's slowing the reaction back to the input again. So one thing we can do is, actually this cap is so delicate that the wire is too fine to engage the inside of the jack very much. Let's see. Well, no matter. Let's see now. If I run this wire in here, the one that's closer to V plus side of things is over here. If I had my Sharpies handy, I could label either side of the board with the correct thing. I'm just kind of eyeing it sharply here, figuring out what I'm doing. So positive side is the input side. Positive side is the near side of this, meaning that if I run a cap into here, it's kind of taking up space that belongs to the other thing. The language of all this gets really tough. Can I run both wires through the same hole? No. Or yes. Yes, I apparently can. Well, that's handy. Maybe we'll run all of these wires over the top of the circuit board instead. All these noises are me touching the microphone. I am not used to having the microphone coming through my speakers. I'm probably going to use non-insulated wires to run to the chip pins just because my non-insulated wires are smaller. If I use the really heavy gauge wire, I can do that, but it's tough to wrestle them together. I'm feeling like what I'd like to do is get at least one of these oscillators actually working for today. And to do that, I'm figuring out what I need in terms of how the connections go. I could fit 3 capacitors on either side of the bank of potentiometers. Then I'll have to be moving the wires around more, but it makes a kind of sense. Maybe that's good. Let's see, we have a problem with the camera in that it's harder to see what's going on. And I keep yanking the microphone cable around, yikes. But I'm definitely not going much past 1, guys. Learning to do this is so stressful, but it's all good. If I bend these wires back and forth too many times, they will also break. That's another challenge. Technically, I don't really need all of these in as long as I've decided that's where they go. So, but I do need them all in for figuring out where to place the capacitors. So let's put them right back again. A spacing of 6 holes each means that and another 6 holes for that. And another 6 holes for that. And I can put another bank on the other side, and then this will all fit. I could also scooch them up a little bit by having them overlap slightly, although it's almost like that's living dangerously too much. I don't know. Might be worth a shot. Oh, hello. One of these is going to need to connect to the ground. I have a ground connection right there. Interesting. It doesn't want to go through there, however, because the wire is one of those large wires. It's too big. Four holes through there. Possible connection for that. These are definitely not going to the same place. 3 holes for that, that's no good. I'm offsetting them slightly. I'm making them staggered. Because there's a trick I have in mind here. There, so that kind of lines up. And the trick is this. If these guys are both ground, because polystyrene caps are not polarized, this can be ground. So I twist these guys together. Maybe shield them somehow if I'm feeling really audacious. then run them over to connect to where the ground is. And then these are now where I connect to the chip. It's getting a little busy in here. There's a lot of these in here. So these 3 wires going out are the ones that are going to have to reach over to the chip. Yeah, I could definitely mount them vertically, you're right. That is a good idea. You mentioned the stream with the Z-plane filter. Well, one of the reasons I can't run my wires over here correctly is because look at that. Yes, I'm still working on the concept of the Z-plane filter. This is the box that contains the Z-plane filter. Although weirdly, this junky little camera can't focus on it, but whatever. I could have made a rail, yeah. Really, what my heart is set on today is making it so that I can have a full-powered, power supply-driven oscillator running on the correct voltage, rather than the dying battery. One that I can manipulate the control and maybe not quite the way I would have hoped. If I have trim pots that don't have these protective things around them, I can glue this onto the part that moves, and then I have a little handle to adjust the trim pot with. Failing that, I got to whip out a screwdriver of some kind. That's normally what you would expect out of getting stuck using trim pots. Let's do that same trick on the other side. Four holes through on either side. This is another handy thing of having this very delicate wire is that we can do this kind of stuff. And it's really quite easy to do. You can see that the bits are falling all over the place. Ah, goodness, close enough. And another 4, and that one goes in there. When I say 4, I mean that there are 4 holes between where the wires are going in. That's just arbitrary. A lot of this gets pretty arbitrary, but I still have to do it. Oh, hello. No, wait. Okay, that's another arbitrary thing. I decided to do this in an irregular fashion. I should have twisted these together rather than these together. I could always undo them, I suppose. It's going to get messy. This is going to get messy and hard to figure out. If that bothers me badly enough, I can just take everything back out again. Like, until it's all soldered together, I can undo any of this. Maybe that would be a good idea. Untwist. or I'll untwist like this. Because these wires are so delicate that you can untwist them and then straighten them just like that. Not terribly difficult. And then these guys are the ones that should be connected together, because they've all got to end up being ground. There will be a common ground for all of these guys. I don't know how well everything is staying within visibility there, but the whole idea of doing that is getting it in such a way where I can do this and it's actually possible to see what I'm trying to do. If I develop this to a higher state, then maybe that'll be something that works and is a thing. And this is indeed the old school kind of perf board with no copper at all, because I would prefer to have it be that way. The way that I'm putting this stuff together, if this was strip board, it would be a complete nightmare getting all of this to work. Part of the concept here is that if I'm delicate enough about it, I can wire all this stuff up and have a lot going on in a very small space. Remains to be seen how well all that works. There we are. So we do have one of these done. Like it's flat, and not only that, look at you coming out. Let's not. Maybe I'll grab my sculpture tool. Sculpture tool. Bend those this way, and then they will be resistant to falling out. See, wiring these directly across is going to pose another problem, which is I have to wire stuff to this in the middle. This is why circuit boards are popular among people. So you can do cool stuff with your dead bug prototyping and such, and it's definitely neat being able to wire stuff up in a little 3D space like this, but I'm not going to say that it's easy, because I wouldn't say that it's easy. Well, back to the challenge. Let's see if we can get one oscillator working and doing one thing. That's one ground connection. Can snip off the spare wire, and then maybe I can use that wire for something. Might come in handy. I'm looking over at some of these other clips as spare wires. Not as handy because it's too heavy. So one of these is wired up. One of these capacitors is wired up, namely this one has a connection to ground. All the other ones are kind of falling out and floating all over the place. Well, let's remove the ones that are trying to fall out. These ones are staying in because the center part is wired together. I can actually loosely loop these together as well. So now that's kind of out of the way, but it's not looped together so tightly that it's really going to be a problem. And this wire is the one that needs to get touched to the input of the oscillator, namely the input of the inverter, the Schmidt-Trigger inverter, which crosses over this place. So if it touches this part that's closer to it, it won't work. It needs to go across there or under it in some way, around it in some way, so that it can get across from, where's a good thing to point with? Oh, yeah, let's dial that down. This thing here needs to get across this wire and touch to this smaller one over here, because it needs to be on the far end of the oscillator. So I'm thinking maybe having it just make a little bit of an arch might be a good way of doing it. Also, these being flat, maybe not great. The mounting them vertically would be easier in some ways, but it would also make it harder to reach the potentiometers, which I do need to be able to adjust, so maybe not great in other ways. The nice thing about this is if I can get this all together and then attach the 2-bit 4-way switch, I believe, we will have a straight up classic symbol noise generator, just like that. Because we'll have 6 separate square wave oscillators, and some of them can be fed into the chips for the switching, and some of them can be the outputs of the chips for the switching. So I have an idea. I do have a bunch of spare wire and a wire stripper, and this is much larger wire than the other wire, so maybe if I pick a useful color like this, seeing as it's touching the input of the circuit, maybe I'll want to use a white color. I can provide insulation for the bit that I'm concerned about. It needs to be about this long. Voila. An insulating tube for the much skinnier wire that needs to not short out against things. There's just a little bit sticking out the end. If I lean that over and solder to the right thing, I'll be good to go. So this is probably a good solution. It's making a little space underneath it. There's a rather large arch there, but that's fine. We're almost there, folks. We're almost getting something happening. At least that's my hope. I am a little concerned that having done this, I've picked such a small capacitor that we might be in the supersonic range once we finally get this done, but that's fine too. With that, I kind of was melting the solder together on these. There. And I can bend it around like this to get it out of the way, because it's insulated, so I don't have to worry about anything. This should be one working oscillator. Yay! So let's see where we got. Maybe we're going to have this thing where it's like, okay, next week I'll do another oscillator. But I mean, if we get somewhere with it, that's kind of the important thing. I keep hearing these noises. That's just me brushing the mic wire. Scoot this out of the way. Where's my multimeter? I want to peek at the, let's see, is this on or not? Voltage reaches 0. If I flip the switch, voltage goes to what the multimeter says is 16, which is not true, although the chip will actually take it, if I'm not mistaken. So those things are correct. We don't have an output wire yet. That's a bit of a concern. In order to tell what this is doing, I kind of need to have an output wire. So let's quickly figure something out. Like putting that on there somewhere. This might work. I'm not sure if I need that many pins. Trying to grab a smaller one without as many pins. We're actually getting back into that show a picture of the thing zone. See, maybe more output pins than I need. Needs to be down here somewhere. So let's maybe pick that as our output. And then run a wire on it, and then run the wire over to whatever it is we're trying to monitor. And perhaps just tack it together with solder very gently. I could drill these out. I am facing a problem, which is this no longer fits. Like, I can't set that flat on the table and solder it anymore because these are taller. I'll figure something out. I'll put it sideways and then maybe pinch it with the pliers or something, or the wire cutters. Yeah, I think the wire cutters. And pinch the legs together so it doesn't fall out. Yeah, I'm nowhere near 18 volts on this. And then figure out how to run this in here somehow. That's going to be interesting after I already bent it. I'll fit it in and then unbend it. If I don't do this right, I'm not going to connect to all of the pins. I'd prefer to connect to all the pins. Where's my tweezers? There it is. Here's what I'm talking about with these big heavy wires. It just doesn't want to be reformed. It doesn't want to be reshaped. Alternate idea. Set that there as a kind of platform. Ah, it came right off. There, now that sits there as a platform. That's holding it in place. And if I can tack it on with solder, got those two pins, but not the other one. That's the other one. Ow, ow, ow. It got real hot against my finger for a second, but I think all three pins ended up making a connection. This is all very improvised. And having done that, trying to move all my tools out of the way. Oh, I'm pleased to hear it. I'm glad that you can still have the sound. Inside of this capacitor, far away, is where this wire must go. I'm not super worried about it being a soldered together connection. I just wanted to make a connection, and pushing it through the same hole that the smaller wire is on is probably going to be good enough. So this is now, should be wired to the triangle output of the first oscillator. Let's test that theory. I'm gonna disconnect this. Don't think I need as long of a wire for that. Leave that. Where's my, these are what I used to clamp it on. They're Bafako knurlies, and there's sliding screws in these rack rails. And that's how I've got this stuff assembled for now. For this particular thing, the Bafako knurlies are actually pretty good. Right now I'm worried with just putting this on so that it's held securely before I solve the rest of it. Very good. So let's scoot some of this crud out of the way and zoom down onto a test area. Alrighty, I'm going to want a wire that runs this far. This one can't. I need a longer wire. I'm going to choose to measure out a red wire for this purpose because this is, after all, V+. Although technically I could also power it off of the yellow for a lower power. Did I remember to turn the power off on that? I guess we'll find out, won't we? That's why I wanted to put some LEDs on there so that I could see whether it was powered up or not. I wanted to be able to see that so that I wouldn't get any ugly surprises. There, the length this long is going to reach. Snip it off. Grab the wire strippers, and I should save all of these extra little bits too. seeing as I'm coming up with uses for them. Who knows when you might need a small amount of insulating material. Since I don't have my LEDs, what I'm going to do is just peek using the multimeter after untangling its wires. Yep, I powered it off. The multimeter back over here. Alrighty. I do have a ground coming over from the power supply, so all I really need is to make another ground over to the new thing. I do think I'm going to want to cut and strip this wire. Or if this is long enough, I think it almost is. Almost is. Well, hey. You can move a little bit closer. And we can use this tiny little jumper. One of the purposes of doing this stuff this way is that these all can be kind of tree-shaped expansion structures. There. Both of those plugged in. So any of these that are connected together can also connect to other things that are connected together and so on. And it can just expand outwards. You can use little short jumpers or longer jumpers or all manner of stuff like that. So and here's our output. Here's the big red wire, which no longer has to be a power connection because it was not long enough, but we can put it back to, and I'll just take a moment to, it is now live. And if we plug it in to here, output of the circuit, good solid connection. What was I doing with this? Damn fino. That doesn't go to anything. Take it back out again. And lastly, the power circuitry for this, with its decoupling capacitor, which is not actually broken. These are rather satisfying to plug and unplug, honestly. I guess eventually you'd wear the things out, but if I plug this in to one of these spots, like that. At this point, the whole thing ought to be hooked up. So I'm going to pad it. And I'm going to step on my mic wire and run it over with the wheel of the chair. Yikes. That ain't nothing but general panic. And I'm going to go and find a screwdriver that I can use for adjusting the frequency, if in fact this does work, which will be done like this. And if we power it on, we should get something that doesn't blow up. There we have it. Now this is a very high frequency little oscillator. And it seems to have a limit as to how low frequency it can go with this resistor. So using the 200K resistor, using the 200K pot, maybe not the greatest of ideas. I do have a smaller one available. I have 100Ks and I have 200 ohms. None of the rest of this stuff is hooked up yet. All right, there we go. So this is another good reason why maybe to not have wired these all in ahead of time. Because it's not actually be the values of potentiometer will want. At least not with the particular capacitor here. And I think we might be able to touch the other capacitor in there and make it go to a different frequency. It's worth a try. The cap is a very tiny cap here. And then the pot is a very high resistance, and maybe this is getting in the way of it being able to do its Schmidt trigger inversion. I'm not sure which direction this needs to be hooked. Actually, one of these needs to be connected to ground, doesn't it? Let's just plug this cap in here. And then see what we get. Sounds like not much. That's definitely it not making a connection. Which one of these was wired up? How is this connected? How about if we... Oh, wait. Okay, so that if this was long enough, I could touch it to... Oh, hang on. So the input section needs to be connected to Here's an interesting side effect to all this. We've got our oscillator. This is ground. And we're taking the output off of the triangle wave part of the oscillator, which is the input. It is where it's getting its voltage and switching between the output stages. Meaning that if we touch that to ground through a capacitor, like on the mixing board, Now we have our lower frequency. Although it keeps wanting it wants much smaller resistances. That, or what we're seeing, I'm seeing a sort of vibration there, might just be the frequency that it's had. Yeah, maybe I'm just dropping to subsonic frequencies. Interesting, okay. That be our triangle wave at a much lower frequency, which is still, however, making a sound. And it'll go right down to subsonics. Yep, now the handy thing about it being this low, I didn't hear it at first. And that's neat, because if we were going to be making something like a kick drum or bass out of this type of oscillator, it's all to the good that the low frequency stuff, I kind of stopped hearing it real fast. We definitely have a wide range of oscillation here. It's very sensitive to what the frequency is. So here's the next experiment. Let's see if we can unplug that after having turned it down really low, and whether we've still got a frequency. Subsonic warning. I think what's going to happen is it's just very delicate in operation now. Oh, or one of my wires just came loose. Never mind. Okay, we're done for the day. Unpower you. Unplug all them wires. Power off the power supply. Well, so this has been interesting in its peculiar way. One of the things I found is that our range of adjustments, is much more dependent upon that cap than I thought. Like the way that it was working, or not working as the case may be, it really wanted a correctly sized cap. Like we're going between 6.8 microfarads and 4,700 picofarads, which is a huge difference. And it's all with this goofy little circuit board. And the reason the other cap doesn't allow us much range is because we're asking so much by trying to charge up a 4,700 picofarad cap, like using a larger resistance means the thing is going to charge up slower. Oh, and I realized why this went funny on me is that was never a solid connection. I was just putting it there temporarily. That's all good. So this, such as it is, with perhaps the incorrect choices for the potentiometers, is the basic guts of what could become a mini shimmery type effect, namely a percussion symbol generator. And I can leave this pod in there because it'd be a pain in the butt to take it out. But I've learned that the other ones, they're too large. They're not giving me a very useful variation. All of the adjustment is like up in one end. And since this is not code, the only way that I can hack that is by using different capacitors or using different sizes of trim pots. And I do have different sizes of trim pots, so that's what I'm going to do. I'll get some much smaller ones, like 200 ohm ones. I have large numbers of those. And see what that shows me. And we'll see whether we can't get and might not be using the triangle wave outputs on those ones. But I can maybe hook this up and then hook up the switch that I was talking about and make that into a cymbal sound. And see, now I'm wondering whether I can show you that. Probably not. Can this wire reach over here? No, it can't. I can't show you. Oh well, that's sad. Not super sad, it's just kind of sad. Hey, yeah, we got an oscillator. I was hoping for 6, I got 1. Maybe next week we can get another. And as this develops, we'll start to get into that zone where I can send people these chips and things, and some of you can try building along with me at home. If this seems like the kind of thing that you would even want to do. You might want to wait until I've built stuff that's worth having. We'll see. But for now, I'm going to get ready to put all of this stuff away. And I will bid you good day.